All right, so welcome back, guys. So we are again having Abhinav Pandey as a guest here, and this is a part two of the earlier session. So if you want to go, want to understand the basic, I'll request you to go to the part one. That link I'll be updating in the description. Okay, so we were talking about the, yeah, welcome back, Abhinav. We were talking about the order flow, the order management system, and Abhinav generously quickly came up with some basic diagram, high level design, I would say. So user is there and he or she is placing order. There's API gateway, there's a auth and validation, and then order service. So a lot of things may come under the umbrella of order service. Okay, so I'll let's see, Abhinav will explore on this further, right? So yeah, Abhinav, over to you. Thanks.
So yeah, I mean, before going into deep diving into this flow diagram, let's discuss first like what will be the requirement, functional requirement and non-functional requirement for this. So the functional requirement that can be for this order service can be like creating the order, like the order service must accept an order creation request from an user and create a new order and validate the order data, like whatever the request that we are getting, it should validate that particular order. So order service must validate that. And the third should be like or we have to, before confirming an order, inventory must be reserved for a requested items. So that should be third. And the fourth will be, we will be initiating the payment, so order service must initiate the payment and wait for the confirmation. And the third, fifth line, last mode, as we discussed in the previous video also, the order state transition, like the order service must manage this order life cycle correctly, like created, payment pending, confirmed, and all the, I mean, this should be. And also like orders must be persisted throughout our database. So there should be, I mean, in this QE will be focusing on data consistency, so that should be there. And order cancellation also can be there, and order retrieval APIs, like let's suppose if I want to retrieve an order, so we should have any APIs that should be like retrieving the order by their ID. So that these all are the common functional requirement that we should may I mean we should take into what we can say that consideration while making an order service. And when it comes to NFR, like non-functional requirement, how the order service must behave. So basically, non-functional requirements defines system quality, reliability, and user trust. So that should be our NFRs. We should take that should be our points to take while deciding NFR. So NFR can be performance, I mean non-functional, scalability, and reliability, and resilience that we talk in the terms of development. So and security, that should be like one of the most important aspect of non-functional requirement. And idempotency, like duplicate request must be not creating, like we should not create duplicate order. So as we have shown on e-commerce website, if we hit on the duplicate orders, that is not, that should not create any duplicate orders in the backend. So item dependencies should be there. And logging and tracing, like we should implement logging and tracing as well, monitoring as well. And yeah, last, I think maintainability, like how we maintain our application. And also like retry and fallback mechanism should be there. So we should also jump into some architecture, microservice architecture of retry and fallback mechanism for this order service. So yeah, that, I mean, functional requirement is nothing but it defines what our order service does. Non-functional requirement is nothing but it will define whether the customer trust it or not. That's it. That's, I mean, if I have to say in the one liners about this from requirement gathering and all, so that should be
All
our
right.
requirement gathering.
All
Yeah.
right. So, broadly, I think we have covered a lot of
Yeah.
topics. Let's talk one each, maybe one minute each. So, failure reports or failure points. So, of course, this microservice or this module will be interacting with several other modules, right? So, in general, what are the failure points you anticipate? Like, There is let's say there's one system, there is three other system. I'm interacting with three other systems at a different endpoints. What could be the failure points?
So, like, let's suppose if you are interacting with, so first of all, you should question yourself why, what fails. That should be why it fails, and uh, let's suppose order request. Let's suppose order request only fails in the first phase only. Order request fails. So, what can be failing? Like invalid request payload can be there, or missing mandatory fields can be there, or some duplicate request is coming due to network retries. So and impact will be nothing but like it will create some duplicate order, it will create customer confusion as well. And so QA should test all these scenarios while and also there can be if I have to say, payment initiation failure also happens, since our order service will be talking to payment service. So there can be we are initiating payment from our end, but the payment service is like payment gateway timeout, payment gateway is getting timeout, and payment is getting declined from the bank. So that there are many things that can happen. So for this, like, we can implement fan out architecture, or like we do have a hell lot of architecture pattern, but we can do some queue mechanism for these failures. We can have some separate queue maintain, and whatever the things are failing, we can put that into that queue, and then we can retry with that queue, with this, like, our retry and failure mechanism will be can be built. That is some basic overview that I am giving, but yeah, you can do anything for this. You can use any queue, or like you can use any other technique to resolve these failures as well. So I mean, yeah. And also, like, there can be, like, let's suppose we are using Kafka or webhook, so there can be webhook failure as well. Due to some network issue or gateway issue. So yeah, there can be different issues, database failure, or yeah, I mean,
Mm.
there can
Okay,
be a
so
lot
I
of
think I think you briefly covered I think 5 to 6 points, major points. Okay, now coming to the next about logging, because having logs is such a good thing while doing backtracing, while QA is reporting issues. So they can give certain logs, or even there are issues when things are happening in production. So production logs can also be analyzed in general. So that so what logging mechanism, or what sort of logging, or any standard way to log certain user actions or system. So what is your take on it?
So, see, I mean, we should have the centralized logging mechanism into our service. Expect like in our whole e-commerce application. So, let's suppose, we should have we do have a different tools like Prometheus, Grafana. That is called log observability thing. So, I mean, we can implement that thing into our application. So, we should have we should use correlation IDs. Why for this? We can generate or accept a correlation ID from an API entry, like from as like from an API gateway, and pass through it for every downstream call, and we can attach that to every log line. So let's suppose your service is failing due to some payment issue, so you will have your correlation ID with you. So you can do what you if you cannot trace one order across your service, you can then logging has already failed. You cannot trace it down. So this, due to this mechanism, correlation ID, you can directly search into your logs, and you can get it to your issue, like what issue your order service is failing. What is the issue? So yeah, that we can follow. This is one of the um, best standard practice that we use by using correlation ID. But yeah, we do have a different we can log the logging should have timestamps, service name, and order ID. By that also, like, we can trace it down our errors as well. So that should be there. Yeah,
Uh,
and
on
with
on
this box become searchable.
on this line, yes, this mechanism is. really going to help. So on this line, because I faced one problem in my earlier companies, so what I see is in the lower environments there are full logs available. There are certain details. Maybe you are using a dummy username or dummy credit card, for example, that is available. But in production, of course, because of security reason, many things are what is the term called masked. They're masked.
Mask thing.
uh,
Yeah, we use
so there's something
mask
called as
value.
logs hardening also, like any
Mm.
or I would say only the super admin or CEO, CTO, they will have access to logs probably. But then for the people like you and me, we are troubleshooting. So what is your take on that hardening of the logs?
So, like hardening of the logs, like let's suppose exposing some card details, some tokens. So we mask that. Usually we mask those details, or otherwise we avoid it putting it into the logs as well. I mean, to be honest, like uh, see, a log should never become your security incident. So that should be followed across your what we can say that logging mechanism, and it should align with your what we can say that we should never expose these details to logs, or also we should implement whenever we will have correlation id. So whatever the error or the whatever the issue that you are facing, that can be easily resolved. Or we can have our structured logs, we can have our straight transition logs, and error category logging also is usually being on the checklist of whatever the system that you are making. So I mean, that's it. And we don't have to over engineer this thing. I mean, just we have to keep in mind, we don't have to expose some sensitive data into the logs. So yeah, I mean, because good logging doesn't prevent failures, it prevent your panic, like kind of like that I have heard somewhere. So like that should be followed. I mean, so we avoid exposing sensitive information into
Right.
the
So
logs.
one thing I also would like to add, like, so let's say a particular microservice is our child. So we are developing it,
Yeah.
testing it, doing the requirement things and all, and we are handing over it to the production team or support team.
Mm.
So we should have sufficient logging, and I would say, we should have this as an acceptance criteria for the production teams, say SRE team or whatever team, or maybe DevOps team, that whenever they are accepting some changes or a new service into their bucket as their responsibility, they should also make sure that the sufficient logging is available, so that it is easy for them to trace and report the issues back to the development team. It is helpful
Yeah.
for everybody, for them also, for us also, and for everybody. Okay,
I mean,
now.
that should be like most. I mean, what we can say that fundamental thing. Like we should have implement distributed logs. I mean, if you have microservice architecture, so yeah. I mean, yes.
Okay. Yeah. So now I'll talk about more from little bit testing perspective. So we have seen, like, there should be the happy path, let's say functional testing. In functional also we have happy path and negative, like positive negative testing. Wherever we see any field, any value or anything which can break the system, yes, that should be tested. And just to give a simple example, if I am able to um, so there will be, some front end where I'll add item to the cart and I'll say submit or place the order. But that
Mm-hmm.
is basically done using APIs in backend, right? So I have access to
Correct.
APIs as a QE. I have access to APIs. What if I enter negative value in the report? Let's say there's a quantity field. I am entering -10 quantity. So I have
Correct.
seen I have examples where I am doing API testing where it is also accepting negative quantity, right? Or even
Mm-hmm.
zero quantity. So zero quantity doesn't make any sense. There's no use, passing this detail to backend and saying there's no order, it's a zero quantity. So
Correct.
that is the negative testing, right? So
Mm-hmm.
happy path testing, negative path testing, as well as non-functional testing. So in non-functional testing, we have other aspects. Just to mention, very typical, we have database testing, we have performance testing, and we have security testing. So in testing, we normally see that whether whatever is being passed from the front end and from back end, is it actually reaching the database in correct tables. Probably a simple select query or whatever, so that is an end-to-end thing. right? Next thing is the performance testing. Yes, though we are considering very simple use case, but then in performance, because it's an e-commerce application, there will be huge load. Let's say typical peak time, morning 9 to 11 o'clock, lot of people are searching and placing the order, or let's say the lunch time, or let's say 4 o'clock to 6 o'clock, again peak time. So a lot of people are searching, placing order and whatever. So how the application is surviving that particular load in that peak time, and can we, there's like scaling mechanism, so how can we scale it on demand? Those things has to be considered. Security testing, yes, as I said, it is also another important part. I can
Yeah.
do penetration testing, where I can mimic, I'm a different user and I can place order, those kind of thing. Or I can, without doing payment, I can simply say, I can bypass the payment. I can say, the payment is done, now place the order. Or returning order, multiple quantity, I'm placing quantity, I'm paying for two quantity, but actually I'm ordering 10 quantity, something like this, right? So difficult to trace. So those kind of things are there part of security testing. Hmm? Right.
I mean, yeah, exactly.
Right. Now, one point I wanted to ask is about the recovery, right? Auto recovery of a microservice. Quickly, can you
Hmm.
explain how can this be taken care?
Like auto recovery is basically the one thing, like I have I mean previously, I mean in our talks, or I mean just now before 5 minutes, I have told you about the fan out architecture, that should be implemented in every service, that will be like auto recovery thing. So what does auto recovery means is like it's an ability of a microservice to detect the failures automatically and recover it from it. Like I mean, they will isolate that particular failing component, and then they will be like restore the normal operation without their manual intervention. So that is what I mean, what we can say that auto recovery means in a particular microservice. So each service should expose like some endpoints like readiness check or liveliness check. So that will be like more health checks kind of thing. In Spring Boot we do have a health check API. So if your service cannot check your health, like its own health, it cannot recover. So it is same as your our human body as well. So if we cannot check our own health, we cannot recover from a particular disease or anything else. So that should be like same for our application as well. So that should be taken care. And timeouts, retries, and circuit breakers, that is what a system design thing concepts that came into picture when like microservice architecture came out. So every downstream call must have a timeout. Like let's suppose we are calling an API, it will be having a timeout. So we will retry only when it gets timeout, or like uh, circuit breakers are nothing but it will stop calling a failing services like that. So it prevents the things. So I mean, there. If I have to say, in microservice, it is not like success is not like nothing is failing. It's not like that. It's like failure doesn't matter. Like that. I mean, if I have to say, so auto recovery, we can implement that fan out architecture into our microservice. So it does what I mean. It has some queue mechanism. It implements a queue, or we can do what we can integrate some AWS SQS or like any queue mechanism. So it will have somewhat. Whatever the failing things are happening, it will be pushing it into that particular queue. And uh, while retrying that particular thing, we can pick up the failure events from the queue, and we can retry that thing. And our retry mechanism will be made with this fan out architecture. And yeah. And I mean, this is one of the aspect in auto recovery. But yeah, I have discussed health checks, stateless services or
Yeah,
like timeouts and circuit breakers. Those are also like aspects in auto recovery in microservice. So we should take care everything, rather than just implementing the fan out architecture is not going to happen. I mean, is not going to help you with the auto recovery. We should take care of that things as well. I
excellent.
mean,
So I really like the term, what you mentioned, failure doesn't matter, because
mm,
I have seen the, based on my earlier experience. So there's a monolithic application, then they make it distributed or microservice based architecture.
correct,
But few services they also implement the auto recovery. So the failure should not matter. That is the best thing I
correct.
would say. That if
Yeah,
any service fails, okay, fine. So let's say in our team, if somebody is on leave, that shouldn't matter. Other team should progress. So
yeah,
that's how it is. So if any of the microservice fails, okay, we understand it is a failure. Maybe we can show some error messages. We stop calling to that microservice automatically, or if there are calls coming to this microservice, this will have a fixed response all the time, that the
correct.
service is down, it is being looked into by some backend team or something, so please wait, or
Yeah.
try after some time. So this is a good thing, good mechanism.
In fact, like this testing, like testability, like if we are focusing more, I mean, we are focusing equally with the testability, it will force you to design the failure, like design for the failure scenarios as well. I mean, it will enforce you to design your system for failure, which is exactly how user experience with the system is. I mean, your system will be more available. Your system will not go down. You will, I mean, receive less failure as compared to uh, other your other applications. So yeah, that should be taken care, and yeah, I mean, that should be like whole aim and game of your application. If I have to say, in short words, I mean,
Okay, excellent. So yeah, very healthy and prominent discussion. Now let's talk about some additional stuff. So from the management perspective,
yeah.
management means stakeholders perspective. What could be the typical expectation from management side? Of course, they have two developers, three developers, one QE, one product owner, one PM working for couple of services. So what are their expectation, right? So can you say one or two points?
So, I mean, see, I mean, if I have to say management or product owners perspective, the one and most important thing, they expect your application should not go down, because they rely on to that. I mean, they have told onto the higher management, yeah, our application will be highly available, so we should take care of this first. I mean, our application should be highly available unless and until failures happens, and we are like humans, and machines can also do errors. So yeah, uh, that can happen, but yeah, I mean, we should take care of that. Your system should be highly available. And coming to the second point, like it should be like it should recover without human intervention as well, like the same scenario that we discussed, auto recovery, we should implement that. And how fast we detect and fix the issues, that is also one of the most important, I have seen across my experience. So that is one of the most important aspect the higher management.
I would like to add one point. So consider a scenario, we developed, let's say, version 1 or version 2. We did all the testing and all, QA, NFR, non-functional, security we have done, and it goes to production. The SRE team takes the responsibility, and now we have sudden issue coming up overnight. Okay, and then there are, the discussions happening. Can we do the testing? I mean, can we reproduce it on the lower environments? Can the developer pick this up? So it becomes easy at that point of time if we have auto recovery mechanism, if we have sufficient logging, if we have the requirements properly told, the steps to reproduce properly told. So this definitely helps at that point of time, based on my
Yeah, yeah.
practical experience. Hmm.
Correct, correct, correct. And I mean, this should be implemented across every application, whether it's e-commerce, rather it's in health care or any industry. They should think about upon this thing, because see, developer I mean, we do have an on-call systems as well in e-commerce. At least one developer is available throughout the, I mean, issues. But if we have this auto recovery, I mean, that will be very helpful for everyone. I mean, rather than developer, with the higher management as well. I mean,
Right. Now, a couple of more points. Uh, Deployment issues. Okay. So,
yeah,
yes, it works on your system. Very, very common. It works on developer system.
that's very
It
common question.
doesn't work on QA, or maybe it will somehow work on QA with some tweaks, but then it doesn't work on production. So, what you can anticipate here?
So, like, see, that is one of the. Even I have worked with many QA members, but I saw. I mean, I have worked with you while I was in Connect UI. So, the same thing I told you, it is working on my system. Why it's not working on your system? So it's like developers' perspective is. I mean, different. I mean, developers only think like whatever feature that I have developed is good. I mean, for our perspective it's working fine. We only test it for only for happy path. We don't care about failure. We just test 1 to 2 scenarios of failure. But yeah, QEs come into the picture. When that particular feature goes to QEs, they list down all the failure scenario first, and then our feature will start breaking down from starting, and we will be like, it's working onto our system. And yeah, a lot of things happens. So that's why we do have a lot of memes on developer versus QAs as well. So
So,
that
coming
should happen, and that should be there. I mean,
coming to deployment issues. So, typically, like, what do you think? Like, this could be one of the deployment issue. For example, let's say some JSON file or a JavaScript file or an icon image or some asset is there on your system, or it is cached, but it missed when you do a check-in, and it missed when you do a deployment. So deployment pipeline is failing. So,
correct.
anything else what you can practically say? Okay, this is what you faced 1 or 2 times. This is the major thing which everybody should take care.
So, like, see, I mean, while committing anything to a master branch, like, let's suppose we have some GitHub repository, so we are committing the changes. So, I mean, whenever we are deploying the things, and that particular file is getting missed, so we should take care, like, while in the code review, that should not going to happen, because opposite person will not be knowing like this file is not there. So uh, after pushing the code into a branch, or like after pushing the things into the branch, so we should do what, I mean, we should test it on local first. I mean, we should test that particular feature once more after pushing all the changes to your specific branch, so that we can make sure, like, whatever the changes that we were expecting is working fine on local with that particular branch changes. Then only we will get to know, like, this file is missing into this branch, and then we can push that changes into that branch, and then we can deploy that particular changes, and your issue will gone. But yeah, we should, every developer should take care of this. I mean, every developer should have the responsibility to check this. I mean, to test it twice or thrice before deploying anything to a higher environment, or anything to QA, or, I mean, dev environment, like that.
All right. So I think we have covered a lot of aspects from multiple angles also, not only dev, not only QA, but management, deployment, and
Right.
discuss the real issues, real challenges. So I think that should be the end for this session. So yeah, we will be definitely coming up with the other microservices or the other things what we discussed in the first session. So yeah,
Hmm.
thanks Abhinav. Thanks
Yeah,
for your time.
yeah, sure, sure. Yeah, we can discuss more things. And yeah, I mean, guys, you have to, like, be with us. I mean, we will discuss a lot of things about this e-commerce in upcoming topics. And yeah, we'll get to know more about the e-commerce internal things, and how the big e-commerce system made. It's just not a order service. with a cart service, inventory service. I will be explaining everything in detail in the upcoming podcast. Yeah, I mean, yeah, and remember one thing, like quality. I mean, quality will be there into our whatever the things that we are explaining. And yeah, just keep up. I mean, be with us. That's it. That's it. And that's what I will be telling, and you will get to know more about the e-commerce system architecture. Yep.
All right. Thanks, Abhinav. Thank you.
Thank you.
See
Thank
you.
you. Thank you. Bye bye.